I'm Marcel Masaga, AI engineer, 5X founder, and fractional CTO. For over 20 years, I've built real-world AI systems, from diagnostic tools used in East African clinics to bootstrap startups that won global awards. I've mentored founders, advised investors, and served on 5 global AI ethics bodies, all to answer one question: how do we build AI that doesn't just work, but matters? This is the Global AI Engineer, where we cut through the hype, think deeper, and build wiser in the age of artificial intelligence.
You keep saying AI agent. So does everyone else. But here's the truth. Most so-called agents aren't autonomous. They're glorified chatbots. I've spent 20 years building real-world AI systems, from diagnostic tools to bootstrap startups, and I can tell you, the hype is drowning the reality. Today, I'll show you what these 7 AI terms actually mean, starting with agent, and why getting them right isn't just academic, it's essential for anyone who wants to build, invest in, or survive the AI revolution.
All right, first up, let's talk about AI that acts. We're moving way beyond just asking an AI a question and getting an answer back. Now we're talking about AI that can actually do things in the real world. And trust me, this is where it starts to get really, really interesting. So let's start with the big one, Agentic AI. Now, I want you to get the idea of a simple chatbot right out of your head. This is not that. An agentic system is designed from the ground up to be autonomous. It doesn't just sit there waiting for you to ask it something. No, it has a goal, and it's built to work on its own, continuously, to hit that goal. You know, it's less like a calculator you punch numbers into, and way more like a truly self-sufficient assistant that you can give a complex task to and then just let it run. So how does it do this? Well, it all comes down to what we call the agentic loop. It's a continuous cycle. First, it perceives its environment. It takes a look around. Then it reasons. It thinks, okay, based on what I see, what's my plan? After that, it acts. It actually does something. And finally, it observes the outcome. Did that work? What happened? And then the whole cycle starts over again. Perceive, reason, act, observe, over and over. This is what lets it learn and adapt all on its own, until, bam, the goal is achieved.
And this right here, this is how you separate the hype from the reality. Look, a simple chatbot, it's stateless. It has the memory of a goldfish. It forgets you the second you hit enter. But a true AI agent, it maintains memory. It holds context. It's not just there to answer a single question. It's there to execute complex, multi-step tasks. It can even use tools like APIs or other software to get the job done. The key difference, the real game changer, is that shift from a passive, "I'll answer your question," to a proactive, "I will accomplish your goal."
Okay, so if an agent has to reason, what's the brain behind that operation? Well, that's where large reasoning models, or LRMs, come into play. You can think of these as super specialized large language models. They've been specifically fine-tuned for one thing: thinking through problems step by step. Before they even think about acting, they generate this internal monologue, this chain of thought, that maps out the entire task. It's the planning phase, all happening inside the model.
And you know what? You've actually seen this happen. Ever use a more advanced chatbot and it pauses, showing a little message like thinking or planning? Well, that's not just some cute animation to make you wait. That's very often the LRM kicking into gear. In that moment, the model is literally breaking down your request, running through that internal chain of thought, and planning out its next moves. So next time you see that pause, you'll know that's the sign of a much more powerful reasoning system at work.
Okay, so we've got an AI that can act. That's huge. But what good is an agent that just makes things up? For its actions to be actually useful, they have to be grounded in facts, in reality. So this next section is all about AI that remembers. We're going to look at how we give these systems a reliable memory and connect them to the real world's knowledge. And that brings us to one of the biggest, most frustrating problems in AI right now: hallucinations. You've seen it, right? An LLM just confidently making stuff up. So the million-dollar question is, how do you stop it? How do you prevent an AI from inventing facts out of thin air? Well, the answer isn't just throwing more data at it or building a bigger model. It's about finding a smarter way to connect it to the truth.
And a huge piece of that solution is something called a vector database. Now, don't let the name scare you. Here's the core idea. Instead of storing words, it stores the meaning of words as numbers or vectors. It does this using something called an embedding model. So in this database, the concepts of king and queen are numerically very close to each other. But the concepts king and, say, cabbage, they're miles apart. It's like a library organized by ideas, not just by alphabetical order.
So here's how that works in practice.
Let's say you take a bunch of raw data, maybe your entire company's internal wiki. You feed it through an embedding model, which turns all that text into a set of numerical vectors. Now, when you ask a question, your question also gets turned into a vector. The database then does a super fast mathematical search to find the vectors from the wiki that are closest in meaning to your question's vector. It's not looking for keywords, it's looking for conceptual similarity. And this whole process leads us right into our next term, Retrieval-Augmented Generation, or RAG. This is the magic that uses the vector database to kill those pesky hallucinations. The name tells you everything. First, it retrieves the relevant factual data from that trusted source, like our vector database. Then, it augments the LLM's prompt by stuffing that factual data right into it.
I mean, the flow here is it's so simple, but so powerful. Check it out. You ask a question, something like, what's our company policy on remote work? The RAG system instantly goes to that vector database, retrieves the exact section from the official employee handbook, then, and this is the key part, it augments your original prompt. It's basically telling the LLM, hey, before you answer, here's the official text, use this. So the LLM then generates an answer that is perfectly fluent and helpful, but it's completely grounded in the facts you just gave it. No more making things up, problem solved.
All right, so now we have an AI that can act and an AI that can remember facts. That's a powerful combo. But there's a practical problem. How do you actually run this stuff at scale without going broke? This next section is all about AI that scales. We're going to look at the clever architecture that makes all this power both efficient and practical.
And here's the problem we're up against. These top-tier, frontier AI models, they're absolute beasts. They're massive, they're complex, and they are incredibly expensive to run. Firing up the whole thing just to answer a simple question, that's like using a sledgehammer to crack a nut. It's a colossal waste of energy and money. There's just got to be a smarter way to do it. And that smarter way is called Mixture of Experts, or MoE. Honestly, this is a brilliant piece of architecture. Instead of one giant monolithic model, MoE breaks it down into a team of smaller, specialized subnetworks. These are the experts. One might be an expert in language, another in logic, another in coding. And then a clever little router looks at your specific task and says, for this, I only need to wake up the language expert and the logic expert. It's way more efficient. You're not paying the whole team, you're just paying the specialists you actually need for the job.
Okay, but for an AI to actually use all these tools and experts and databases, it needs a standardized way to talk to them, right? It can't be a custom job every single time. That's where AI native protocols like MCP come in. The best way to think about this is it's like USB for AI. It's a standard plug, a common language that defines exactly how an AI can safely and reliably connect to all these different external systems.
So what does this really unlock? I mean, pretty much everything. With these standard protocols, an AI agent can now securely connect to external databases to pull live data, it can tap into code repositories, it can connect to your email server and actually manage your inbox for you, it can even hook into payment APIs to process transactions. This is the final piece of the puzzle. This is what takes a language model from being just a fancy text generator and turns it into a true, autonomous digital worker that can interact with the world.
And for our last section, let's zoom out, way out. Let's look beyond the systems we're building today and talk about the big theoretical ideas that are pushing the entire field forward. This is AI that transcends. This is about where all of this might, just might, be heading. Now, you've probably heard the term AGI thrown around a lot. Artificial General Intelligence. That's the theoretical point where an AI can perform pretty much any cognitive task as well as a human expert. That's the benchmark. But there's another level beyond that, and that's ASI, or Artificial Superintelligence. This is a purely theoretical concept right now, but it describes an intelligence that doesn't just match ours, it completely and utterly surpasses it in every conceivable way.
And the core idea behind ASI is, well, it's pretty mind-bending. The theory is that it would be capable of what's called recursive self-improvement. What does that mean? It means the AI would be smart enough to make itself smarter. It could literally redesign and upgrade its own intelligence, which would then make it even better at upgrading itself, creating a feedback loop, an endless cycle that could accelerate at an exponential rate. It's a staggering thought.
And so that leaves us with the ultimate two-sided question, doesn't it? An intelligence like that, could it solve everything? Could it cure disease, reverse climate change, and poverty, all of humanity's biggest problems? Or could it create entirely new problems, existential risks so complex we can't even begin to imagine them today? It's a future that is both incredibly promising and profoundly terrifying, and it's a concept that absolutely demands our attention right now. If you found this valuable, do 3 things. 1. Hit like below. It tells YouTube this content matters. 2. Subscribe and hit the bell because next week I'm breaking down the one-phase 99% of AI startups skip and how to use it to ship faster. 3. Watch my latest video, Artificial Intelligence is a Lie. Here's what we're really building. It's already changing how engineers and founders think about AI. I'm Marcel Masaga. Thanks for being part of the Global AI Engineer. Until next time, think deeper, build wiser, lead with courage.